Welcome to the Podlets podcast.
Hello, and welcome back to the Kubernetes podcast, episode 2, Container Orchestration. My name is Nicholas, and joining me this week are Carlicia and Josh.
Hello,
Hey, guys.
everybody.
Hello.
Good to be here again.
Yeah. So how was your week, everyone?
Very good. Lots of work.
Yeah. Anything exciting happening in the world of Valero?
Yes, we just cut our alpha release for version 1.0, and we are looking for
Nice.
testers. Yeah, we want testers.
Awesome.
And I've been traveling a lot, but it's been good. We're doing a lot of interesting work with some Kubernetes clusters running in an on-premise data center, which is something we see less and less now that the cloud providers are kind of taking on their different offerings. So it's cool to hop back to kind of the bare metal and virtualization space and play around there.
Oh, that's cool. So I've actually got a question for you guys, kind of irrespective of container orchestration, but how do you guys manage travel, right? Like, how do you keep yourself entertained? How do you keep yourself happy while you're traveling? For me, it's a lot of podcasts, which is great now that I'm doing a podcast.
Yeah, so I do podcasts. I signed up for YouTube Premium so I can download videos.
Mm-hmm.
I watch the movies on the plane. I have a Kindle with lots of books.
Yeah, that's nice.
Yeah, or I just sleep.
I wish I could.
Yeah, sleep is always the first goal, but I also signed up for YouTube Premium, and the offline feature is fantastic. So there's so much good info on YouTube. You know, it's great to like go to the KubeCon playlist and just choose offline, and then you have all that time on the plane to really sift through talks and whatnot. So it's been really, really cool.
Exactly.
That's a great idea. I've actually not used YouTube Premium for that. I've only ever used it for like meditation tracks to use on the airplane. So like I spend some time in the airplane kind of just in my own head a little bit, kind of doing some internal self-care, if you will.
Nice. But
that gets boring every so often.
I meditate too. It's great.
Yeah, it's good. All right. Anything interesting in the cloud native space that you guys found in the last week?
I have a talk that was accepted for KubeCon China.
Oh, awesome. Congratulations.
Thank you.
Congrats.
Yeah, it's a joint talk with Stephen Wong, also from VMware. We're going to talk about data recovery, data protection, recovery, migration in Valero.
Oh, that's great. He's been coming to the Cloud Native Social Hour pretty regularly. So that's awesome to see some more cross interaction.
Yeah, he is awesome. So knowledgeable.
Great. And Josh?
Very cool. So I was actually looking this week, since I'm in kind of the Kubernetes mindset, for something that can kind of add a TTL to any Kubernetes resource. So think of something like, I have a service account in Kubernetes and I want to attach a TTL to it such that in 4 hours, it effectively gets swept up and is no longer existent in the system. And there's some interesting ways that actually KubeADM, one of the bootstrapping tools, does this. And I was trying to kind of replicate that for their tokens. And there's a project by one of the Zalando folks, Jacobs. I don't know if that's his last or first name. Sorry in advance for butchering it. But he's got a project called KubeJanitor that does effectively that. So with annotations, you can put a TTL on them, your resources, and then KubeJanitor will just come through and sweep that up. Which is, I thought, a really cool idea. So that was an interesting thing that I saw. It's no new news. I think it's been around for a while, but it was the first time that I had run into it.
Oh, nice. For me, our co-host Duffy turned me on to a tool called Chaos Blade. Recently, I've been getting more and more into chaos engineering, and this is apparently a easy-to-use chaos engineering toolkit. And it's something I've only just started looking at, but I'm pretty excited. So I'll probably be playing around with that a bit more.
Cool.
Awesome. Yeah, so this week on the podcast, we are talking about container orchestration and kind of what that is, right? For me, like, container orchestration is the idea that you need your workloads to run somewhere, but you don't necessarily need to care where they're running. And the way that this has been done traditionally, like prior to container orchestration, was like scheduling VMs or making sure these processes run on certain computers, right? There's a lot of automation around that with like when containers came around, we needed some way to, make sure that they're running. And it also enabled us to not need to care so much about like how things get started and all that. Everything was kind of packaged in a container. It was containerized, right? And so they needed to just be some way to run them. And so that's kind of where container orchestration came in. Is that kind of your take on that as well?
Yeah, so basically when we say we are orchestrating containers, we're basically tell them how to behave, right? So for example, I have this container here and I'm going to declare that if it fails, I want it to come back up. And this container over there, if it fails, just keep that state. Don't do anything. And then I might say, hey, I want 2 of you, 3 of you. I want to, the orchestration part is really just dictating behavior and state.
Yeah, absolutely.
Yeah. And I think one interesting thing that came with the advent of containers is we used to have this notion of, what server is my application going to land on? Or then eventually, what virtual machine is my app eventually going to land on? And we think kind of in these units of virtual machines. And the paradigm shift a bit, at least in my experience, has been now that you have the container unit and you can run many of those on one virtual machine, right? Your concern about orchestration is not just putting it on machine A and putting it on machine B, but it's kind of like packing multiple of these containers, perhaps on the same virtual machine or same host. So the orchestration notion is beyond just the conventional, system construct of a different host each time. It's really interesting.
Yeah, and I think it might be important for us actually to take a step back. I realize I kind of jumped right into it, but we should probably establish what a container is, right? Before we can talk about how we orchestrate them. So a container is basically just a tarball, honestly, that is a packaged application with the instructions for it to run on any system that can accept that tarball. And containers are broken down into a couple of Linux constructs, C groups and namespace. So C groups for making sure the process runs in its own like dedicated memory, and then, or just like isolated memory, and namespaces for things like network isolation, so that the network traffic that's going on in the container doesn't cross over to other processes. So very controlled process, like initiation, based on these instructions. And that's kind of all a container is. A lot of people think that they're like kind of like a VM. I've heard that a few times. We're like, oh, well, how do I deploy it? Like, what's the kind of the VMDK for a container? And it's like, oh, it's just a process that runs on a computer in a very controlled fashion. That's literally it.
Yeah, and it's kind of interesting to think like at what point in which we kind of started using containers and seeing containers. So I'd be curious for either two of you, Carlisi especially, what was your first exposure to like the unit of a container, and why were you starting to consider using a container versus, just a virtual machine or a process?
So frankly, I don't remember. I mean, for my first time seeing a container has been a long time, but I don't even remember. But probably maybe trying to do some application, like some toy application that was an example application. And I remember that I was working on an application that we had the option to stuff it into a container as well. But I personally, during my the development, I wasn't using it for development. So my first usage of container really was about 3 years ago when I was working for a CDN. And so a CDN, as you might imagine, has many different parts. So it has very low-level software running to higher level software, right? So like really sometimes, well, not sometimes, it has kernel level applications in systems, and it has API level system. And for you to develop one part of it, it was really handy to be able to stuff all of these different systems into containers and have containers talk to each other. And we weren't using it in production. This was for development, but it was amazing. It was fantastic. We would have applications developed in Go, different systems that needed to talk to each other, and we would have applications in C and anything else I don't remember, but it was amazing. So everything in containers. And then we had a tool as well that was sort of like Kubernetes. It wasn't Kubernetes, it was developed in-house. That orchestrated all of these things, and if something failed, bring it back up, and did a bunch of other things as well. I cannot explain the difference of working like that. It's so much faster, and so I could be a lot more autonomous, being able to run everything myself. I didn't depend on having access to a server. I ran everything on my laptop. It was fantastic.
Awesome. Yeah, the first time I ran into a container was back when I was working for Red Hat, right when OpenShift 3.0 came out. So that's when OpenShift kind of moved from the in-house version of OpenShift to adopting Kubernetes. And I had been working mostly in the virtualization infrastructure world, doing Red Hat Enterprise Virtualization Manager, which is kind of like a Red Hat take on vSphere, kind of, and so I was very used to virtualization and spinning things up. And so there are some aspects of creating a VM and creating a container that were very similar. And so it took me a while for my brain to click. Once I started using OpenShift to kind of click into oh, this is how they're different, right? But whereas if you just start looking at it, you're well, what's kind of the difference? They're all just in my command line, they all just come up as lists of units, right? And you're oh, this is a processing unit, that's a processing unit, right? They're kind of similar, but once you start really getting into the use of it, it was so much different. So I had heard during this process of switching over to these two tools, I had heard of Docker, and I was oh, that's something I'll take a look at. And finally, by shifting over to OpenShift, I finally was starting to oh, this is what Docker is. This is how we use these, and then kind of digging into containers there. And so it was an interesting switch from an infrastructure standpoint to oh, this is how people use containers. And then that kind of actually started getting me into development. It was now that I didn't have to care about all this overhead of where do I put my application, if I want my application to run on my computer versus your computer, how do I make sure that the packages are the same, blah, blah, blah. And so once there was that easy way to kind of say I just want this to run everywhere, no matter what, hopefully, that really just fascinated me, and I kind of took off from there. Josh, how about you?
Yeah, my experience wasn't too dissimilar. What was interesting is the space I was working in was a lot of legacy Java applications. So we kind of came to containers probably a little bit later than what some of you all did. And what was always interesting about it is, we started to really see the value of containers, just like Carlisi was saying. We started packaging these apps up, and they ran the same in every environment, and just really changed our workflow around. And initially, it was just let's figure out a way to simply start these containers on different hosts. So, whether it be Ansible or even someone going on a host and typing Docker run, that was how we got these processes to start. And as the adoption of containers grew and grew, and more containers started to come to life in this company, the need for orchestration finally became obvious, right? Because I had heard about this project called Kubernetes. I'd heard a bit about Swarm, Mesos, and it was always just I don't understand why you'd ever need something this complex, right? But eventually you hit this inflection point where it just becomes insanely obvious that your life is potentially going to be just chaos without something that can actually figure out, hey, you need to run this container. Let me figure out where to put it and make sure that it starts. And I thought that was a really interesting progression. And it used to be really hard also to navigate the options, because there were a lot of options, and there still are. There's Swarm, Kubernetes, OpenShift, Mesos, so on and so forth.
Yeah. And that's actually a good point, something to talk about, is that container orchestration, it seems like we were all kind of building up to the same point where when containers were kind of taking off, everyone started to see like, oh, this is great, but how do I do this at scale, even like remotely at scale? And so a bunch of people started doing their own thing. So there was Kubernetes, which is the open source version of Borg with some changes to make it more friendly for other people. There was Docker Swarm, and then Mesos, Rancher. But then Carlisi, your team they had their own orchestration, and a lot of other companies have their own orchestration as well. So it's not just, you don't need like this project to do, or any of these projects to do container orchestration. You can do it on your own if you need to, right? So like for example, we could take a look at Uber. They aren't using a project. They've rolled their own container orchestration at scale. And I think that's insane. Like that's crazy to me, but that's awesome for them to have pulled that off, right?
Yeah, absolutely. And and when I think of container orchestration, there is the management part and the scaling part. Because when we think about management, for example, I might need a whole set of services to be up and running before I can run the set of services. So the orchestration is going to manage that for me, ensure that the services come up, they're up, and now this set gets kicked off. And that if I don't need to scale, I still need to do this, right? There is usually some sort of dependency. And then the scaling part, which is also, it's important for a lot of companies, but it's not important for a lot of companies, smaller sized companies, right?
Mm-hmm.
Maybe we can talk a bit about what kind of information container orchestration works with to determine what it should do, if that sort of makes sense. Like, what kinds of things are we telling these systems about, and then what is it doing to act on that information?
Yeah, please go ahead and dive into that a bit more.
Yeah, so I guess it seems like the common approach that we've run into, at least with Kubernetes, and I think it's true for a lot of these different systems, is the notion of reconciling state, right? So we start off kind of with a declarative, a definition, if you will, of what we want the world to look like. And that could be some app running with some amount of replicas when you want it to be, have a certain amount of CPU and memory available. And then these orchestrators usually can just take that declarative notion and sort of act on it, right? And I know, Nicholas, you're really close to Kubernetes. Would you want to speak to like how exactly it acts on those things? Like when you give it that declarative API object, like what it's going to do behind the scenes?
Yeah, so in Kubernetes, there's a couple different systems at play, and this is something that I find really fascinating. There's a lot of reconciliation loops in many different places. And so in Kubernetes, when you first declare to Kubernetes that you want something to happen, you talk to the API server, and the API server then modifies the etcd data store, right? So the etcd data store is just a very simple key value pair brain. It's like the brain of your Kubernetes, right? And so only the API server, as far as I'm aware, like remembering off the top of my head, that's the only thing that actually directly communicates to the etcd server. That might be incorrect, but for the purpose of this,
I think that's correct.
Okay, good. I was suddenly second guessing myself. So the API server directly communicates to the etcd server and makes the changes. Then the controller manager is in a reconciliation loop saying like, okay, here's what I think the world looks like. And if the world changes based on like what etcd is saying, so like the controller manager maintains actual state and etcd controls expected state. So this is where we want to be. And so if actual state and expected state are different, the controller manager reconciles that. So either it will delete something or add something to the cluster at large to make sure that that state exists.
Based on what's in the etcd database.
Yes, exactly. So the controller manager, based on all the many controllers that are just themselves reconciliation loops, if any of them are, different, it will then kick off something to the scheduler, which will then inform the various nodes in the cluster what changes they need to do to reconcile state. And so then those changes occur, controller manager sees that actual state, matches expected state, and everyone's fat, dumb, and happy.
And we actually didn't talk much about other container orchestrator. Why am I having trouble with this? Container. Say that 3 times fast.
Container
orchestrators.
Yeah. And that's
other than Kubernetes. Sorry, Nick.
No, I'm sorry.
But I'm wondering, because I am totally not familiar with any other, but 2 come to mind: Docker, Swarm, and Mesosphere. Do they operate in the same way?
So, Josh, I think you had some more experience than I did with, at least, I believe it was Mesosphere?
No, unfortunately not.
Oh, I thought... Oh, okay. I thought that you'd used, in your previous life, you'd used at least one other.
No. We did some small proof of concepts on Swarm, but we never got very far along with it.
Yeah, I actually, to be honest, I don't really know much of the difference between like Rancher Lab, Mesosphere, and Docker Swarm. I believe that they all act very similarly to Kubernetes, but in slightly different way. And this is something that I meant to take a look at before talking about it, but I just ran out of time, I'll be honest.
I guess we're going to need part 2 to this episode.
This is a big topic. We'll definitely have to come back and kind of launch on this a bit more. But I think that all orchestration and all these orchestrators work in the same function, right? Or the same fashion. There's what you want to happen, what actually exists, how do we get that change to occur, right?
Was that what you meant, Josh?
Yeah, exactly. And I think the one thing to add too is these systems are generally making like really informed decisions when trying to reconcile a desired state, right? And by really informed decisions, I mean they're obviously aware of a lot about the compute resources available to them. So one big benefit that adopting container orchestration gives you is things like the scheduler are able to look into the system and understand, hey, based on resources I have available in this area, it would be smarter for me to start more containers over here versus over here versus over here, right? So when you have these larger complex things and you're trying to kind of think of all of your resources as kind of like a sea of compute, the container orchestration is not only able to get you to a desired state, but also to do it in a way that is, at least in most cases, as desirable as possible, right? As far as using resources effectively. And a term that we oftentimes throw out there, which is bin packing, right? The idea of ensuring that we can know the resources a container needs and then pack them together really tightly so that we're utilizing the potential hardware or cloud resources that we're paying for every month. So a lot of times the adoption of container orchestration is this really elegant way to move our workloads around, but at the same time, it's a way to really utilize the things we're paying for and potentially cut costs over time as well.
Yeah, this is one thing that I find fascinating with at least Kubernetes, because I haven't used the other orchestrators. We can boot up, let's say, 4 machines and 4 instances of a machine and deploy Kubernetes on it and tell Kubernetes, I want these many nodes, these many pods, and I have these container with apps, obviously, or services running in the containers. And I don't need to specify even where anything is going to go. It just spreads the load and keeps managing and monitoring and managing what needs to go where to better utilize the instances.
Mm-hmm. And I think that's actually an important distinction between the different container orchestrators that exist out there. If I recall correctly, I believe that Mesosphere has a mechanism that can kind of better load balance your application, your containers that are running in the cluster. At least better than the way it can make a kind of a more informed decision on like the state of the cluster and where to place things than Kubernetes does, and that might be one of like the key differences between the two. And that's something that I hear a lot in the Kubernetes community. Someone's like, "Oh, well, I noticed that all of my resources are kind of being put onto one computer, and then the rest of them aren't even being utilized at all. Like, what's up with that?" And I think that's important. There's something there that's important to understand, which is the bin packing that Josh was talking about. Also, I pointed like that because on my screen, Josh is right next to me, but that might not be the case. So it might just look like I'm pointing off into space. It's important to know that from the capacity of, like, at least in Kubernetes and like most of these orchestrators, if there are resources to be utilized, the orchestrator doesn't care for the most part. Like, Mesosphere has the ability to kind of like load balance, as I said, but as long as the resources that are available on one computer are the same as any other computer. So if one of them is getting like super utilized and the other ones aren't, it doesn't really matter. It doesn't affect the functionality of the cluster at all, right? 1 meg here and 1 meg there are essentially the same.
So what does the orchestrator do when, let's say I have 4 instances and I have what I have. I stuffed a bunch of containers in there, and I'm thinking, well, those 4 instances will give me plenty of memory, but I have a leaky app and all of a sudden my RAM blows up. What happens?
So, sorry, Josh, I'm going to take this one. This actually ties into why I love container orchestrations from a cloud native perspective. And this is kind of where container orchestration is cloud native. It takes in account the elastic nature of your resources. So if you have this application that's blowing up, either you can have limits to how many resources the application can utilize, or you can use autoscaling. So we have in Kubernetes, we have something called horizontal pod autoscaling, and in some of the other tools, I'm sure they have the same. But the idea is, like, as you're using more and more resources in the pod, it's taking up this much memory. It then needs to create a new pod, right? And so, or a new container, right? So a new container needs to get orchestrated, and then another one. Now, if you have a really aggressive application that's acting kind of maliciously, that's not great, because that'll take up all the resources in your cluster, and that's not good. But if you just have a very like spiky application, it can grow with its needs and then come back down, and no one has to know about it. Essentially, your orchestrator can make that happen for you. And I think that's really cool.
It is. And what if I am reaching the limits of my resources? I mean, there are only so many pods I can stuff in 4 instances or 2 instances. So what if I am reaching the limits of my resources? What happens then? How is an orchestrator going to help me?
Yeah, the nice thing is we can, in most of these orchestrators, set some type of parameter around potential CPU that we want to make available and memory we want to make available for the app. And what's nice about this is, at least speaking to Kubernetes, I'm sure it's similar for others, just using kind of some of the underlying technologies that already exist in Linux, like Nicholas had mentioned, C groups. We have the ability, when CPU gets too high, to potentially throttle it and kind of slow it down, or at least limit the amount of CPU it can use in given cycles. And with memory, if we start kind of overcommitting, we even have the ability to potentially kill the application if it's starting to take up more memory than it actually should be allowed to take up. And what's kind of interesting about Kubernetes and other orchestrators is their kind of self-healing model is that sometimes when apps are doing really bad things, like leaking memory all over the place, you might not detect it right away, right? Because it's actually going to potentially limit or kill the app and self-heal it by bringing it back up. So it might seem like your app is still online and you didn't necessarily realize that under the hood, Kubernetes was actually restarting it and trying to continually bring it to a state of health, right? So you have a lot of abilities. It's like everything that Nicholas just said about reading how much information or resource the app is taking and potentially scaling based on that, or even setting like hard limits to say, I want to throttle my app or even potentially kill my app if it starts to act badly and use up more than it should. So it's a really cool kind of declarative way to approach resource limiting.
It really is. Sorry.
Yeah. No, it's okay. And that's actually something that I don't think a lot of people, including myself, work on that much, is the throttling aspect, right? Most people are like, okay, well, whatever, just take up as many resources as we need. That's what it's there for. But maybe you shouldn't always be doing that. Not every application needs to expand horizontally or vertically if it's a stateful set. It could be that the application is acting poorly and you need to be like, no, you actually don't need that many resources.
So let's say any or all of these things are happening, throttling, and self-healing, and how could I know? I mean, I'm asking this question, but I know the answer. I mean, what tools do people actually use to be informed, notified of these events?
So this is something that I think we're going to get on another episode, but just to kind of breach us into, this is something that I am also very excited. I'm just a very excitable person, really. I'm like, people have described me as a puppy, and they're not wrong.
That's why you're here, Nick.
What? Wait, who said that? Is observation or observability, right? So monitoring, alerting, inflecting into your cluster to know what's happening, right? So you could, as Josh was saying, like under the hood, these things could be happening, and the orchestrator is reconciling your cluster and your resource utilization for you, and you might not know it. But if you have observation and you have monitoring going on, you can see like, oh, hey, this pod is like restarting every 20 minutes. Like that, it shouldn't. It doesn't need to restart every 20 minutes. Like clearly the application is still running, so that's not a bad thing, but maybe we should fix that, right? So you can become aware of what's going on, right?
And I know that there are tools that provide monitoring and observation, but Kubernetes itself doesn't provide that, right? Those are things that we hook into Kubernetes.
Yes. Yeah, that's correct. Because Kubernetes and like any of these other orchestrators are doing what they should be doing, which is being the best orchestrator they could. Having like that package, now that you're getting into something that's more of like a product. And there's nothing wrong with products, but that's not what these projects are here to be, right? How
do you distinguish between a project and a product?
No, that's interesting. Josh, do you want to take this one?
You open the door.
I will. I'll start, and then I actually think, Nicholas, you might be the best one to speak to this with your background on OpenShift, quite frankly, right? So it's kind of like these orchestrators are a primitive in a way for how we eventually build a platform. And that platform is a larger thing that includes potential monitoring, maybe plugins to continuous integration and continuous delivery. And there's a lot of groups or companies that have kind of that whole story, or at least parts of that story packaged up together, right? I mean, we do it at VMware with some of our enterprise offerings around PKS. And then OpenShift, at least in my mind, it kind of does that as well. And maybe, Nicholas, you can speak to that a little bit.
Yeah, so from an OpenShift perspective, at least when I was using it, it was trying to be everything that you would need to monitor to run a container orchestration system, right? So it has a Docker registry built in. It has monitoring built in. It has some rudimentary chargeback built in, ingress, all these things that don't necessarily come with Kubernetes, like the upstream Kubernetes. It has a solution around that. And I think that's the difference between like a project or just an orchestrator and a product. A product is trying to solve a grander enterprise problem versus a project, or in this case, an orchestrator, is just trying to solve one problem. And that problem is, how do I get these containers to run in the way that my users expect them to run?
Yeah, fair enough.
And what do you think on the topic, Carlesia?
Well, it sounds an awful lot to me like a product is you get money for it, and the project you don't.
That's actually you're right, honestly. That is really the main distinction. One of them is money-based.
But your description is, the descriptions you gave are very valid. It's very valid because a project by itself might not have enough value for, let's say, companies. Mm-hmm. And bundling this project, that project, and the other projects, which ultimately you're building a product with a purpose, right? You have a purpose for that product. You have a specific audience for that product, set of users. And so it's very distinct from taking one part of that product and calling it a product, because maybe it's not enough to address solve problems.
Mm-hmm. Yeah, I think that's like an important distinction. It's almost like what Nicholas and I were talking about was more about the distinction between what an orchestrator is and what a full platform would be, right? And I think Carlisia's point about like how we plug in the monitoring and stuff is really important because, you know, just like we were talking about with the cloud native landscape in our last podcast, like Kubernetes is just one piece of the overall puzzle. Kubernetes isn't your whole platform start to finish, right? It's just the container orchestration portion. And you have a lot to build and hook into that to make it a full platform that, you know, your company might be onboarding developer workloads onto. It's really just one piece of that overall puzzle.
That is beautifully put, Josh.
Yeah, very nicely put. So I've got a question for you guys. We've kind of been beating around the bush, as it were, but to me, it seems apparent that in the world of container orchestration, Kubernetes has come out on top. That isn't to say that it's the end, right? There could be something, you know, that comes out that actually beats Kubernetes, right? But for now, it seems like everyone is looking at Kubernetes. And I'm kind of curious why it is that you think, you all might think that Kubernetes took the top space.
I'm scratching my chin.
You're the scratching chin emoji?
Exactly. One thing for sure is I just think Kubernetes did the community thing really, really well. And not that it's all about community, it's obviously about technical choices and things of that nature, but I think they did, not to say they're perfect, but they did a really good job of being very inclusive and getting people to join this community and give feedback, and the structure of the special interest groups where people get together and focus on various areas of Kubernetes like scheduling or cluster lifecycle and things like that. And it's interesting because the community just grew so quickly in my mind that it just kind of made this massive push into the market because there were so many humans behind it pushing it along. So I think, at least among other things, community was one of the biggest.
I can't say that I was paying attention and monitoring that space, so I don't know. Of course, I can make guesses. What Josh just said sounds very plausible. You know, that he had Google behind it, I'm sure it didn't hurt. Is what it means. It's not that Google is not that we need to be fanboys and fangirls of Google, but having a company like that sponsor and put resources behind the project gives a signal that, okay, this is going to be here for a while. Even though Google has sort of a reputation of discontinuing things, but at the same time, I think that is significant. What else? Definitely the community. I didn't follow the community from the beginning, so only this last year and something, almost 2 years that I've been working with Velero, that I get to see how the community is, and it's amazing. It's crazy, so organized. Yeah, no, it's not perfect. Nothing's perfect, but it's incredible. The enthusiasm and the organization and the transparency.
Yeah, absolutely. And I agree with actually both of your points. It's corporate sponsorship, not just Google. I'm going to get to this in a second, and the community as well, and also some of the functionality. But it was both the corporate sponsorship of Google and Red Hat in the early days. And not to like tout my old, yeah, we did it. But it was Red Hat had a big play into early Kubernetes as a supporter. And so what that kind of did was establish, hey, Kubernetes is at least an enterprise perspective project, right? It's not just, hey, this is some open source project. It may or may not work. If it doesn't, you're kind of on your own. If you had a company like Google and Red Hat who are both endorsing this project, suddenly enterprises were more interested in taking it on board.
Yeah.
Like it was more of a viable concept.
I'm glad you were here, Nick, to correct me and make that addition.
Oh, yeah, I'm not correcting you at all. I think...
No, because I didn't clue into the fact that, I see Red Hat all over the place, but I don't know the dimension of involvement that they had from the beginning. Because at the beginning, I was an outsider to all of this.
Yeah, so for perspective, OpenShift 3.0.0, which is when I first started getting into it, is based on Kubernetes 1.2, which is pretty early. And they were big, like put a lot of resources into the development of the community and for the development of the functionality that exists, right? The horizontal pod autoscale that we still use today is due in a large part to the contributions of Red Hat, right? The engineering at Red Hat is kind of responsible for that piece, right? And among other things, right? And so with them at play, kind of getting their community and Google's community coming together and then able to organize this community, that I think is a big piece of like what took this off, right? Or what allowed Kubernetes to take off. That's how grammar works. There's also some pieces of like functionality that I think were kind of novel to Kubernetes in the early days, things like ingress. And then the way the kubelet worked was actually kind of unique. Like how just low level the commands that were being issued by the kubelet were pretty unique. And so it allowed for people to adopt it. Like the things that were happening from the kubelet perspective, like changes to your IP tables, running a container, like changing the C groups and all these things, those were all well known by people at the time. And so there wasn't anything like arcane happening. It was just, hey, this process just runs these commands. And that's how it reconciles state, right? And so I think that kind of functionality really got people to trust what was happening. And so, it's like, I think the trust and transparency are like the big things that people kind of keyed into. Like the trust comes from the enterprise sponsorship, and also the fact that what was happening from a rudimentary standpoint was pretty simple, and so people could wrap their heads around it. And then transparency was having this community. Everything happens open in the open. Everything is recorded and accessible by everyone, right? It wasn't just like some behind the scenes thing happened.
Yeah, and I think that piece is super important. Like, Nicholas and I, we came from CoreOS, so our lineage around like open source Kubernetes is not too dissimilar. And we spent a lot of time working with customers in pure upstream open source Kubernetes and actually taking some of their issues and requirements to the community and then helping shape the direction of Kubernetes in micro kind of ways, but still important ways to that company. And I think companies seeing through, the CNCF and seeing through just community leadership and involvement that the things that they care about aren't just going through a single vendor to make a decision as to whether that thing should be included, but is being part of a larger community discussion, breeds a lot of confidence in this project in the long term. I think at the end of the day, kind of like what we started with, there will be a container orchestrator that many of us use, or maybe there'll be a couple, right? There's no question we need to solve container orchestration as an overall problem. And companies are at this point where they're still kind of placing a bet on what they want to use. And because of the community, because of the involvement, because of the ability to adopt the project to potential business requirements, I feel like more large and small and medium organizations are willing to put their money on Kubernetes as a whole. And I don't think they felt as confident behind some other projects like OpenStack and historical Mesos perhaps. And I'm just projecting based on conversations I've had, but that's kind of why I think a lot of folks are really excited about the future for Kubernetes.
Yeah, that's an excellent point.
Let's stick with the theme of projecting and future, and we are going to have to wrap up soon. Otherwise, it's going to be this could be a 2-hour show.
Yeah.
But let's not make our audience go through that. We'll have part 2.
Mm-hmm.
What about, we talk all the time, and people who are in this area, we talk about all the time how everybody knows Kubernetes and but I want to challenge you to say, do you think that everybody knows Kubernetes? Everybody knows the purpose of Kubernetes? Everybody knows if they should be using Kubernetes or not? Like, how are people able to make an informed decision if they should be using Kubernetes? Because I don't think everybody knows Kubernetes. I think the majority of companies, in terms of volume, because smaller companies, I think I would guess they outnumber the bigger companies, and technologists. I think there are a lot of people not clear on what this is. That's why we are here. But what do we tell them? Like we have to have an episode to just cover that. Now that I'm thinking about it, but
Yeah.
I think we could wrap this up with some like seed ideas for that.
Yeah. So that is a great idea. And something I was kind of like playing around with introducing myself is, when do you not use container orchestration, right? It's just because container orchestration exists doesn't
If you don't have containers.
Yeah. One, if you don't have containers, that's a no-starter.
It's a real legit thing to say, because some people ask me, should I start with Kubernetes or containers?
Yeah.
That's the level of education that we must provide.
Yeah, absolutely. And that's something we actually run into a lot in the field is when we're engaging with our customers, part of our job is to help containerize their applications if they're not already there, right? And trying to help them do that in a logical manner. But for instance, to talk about to give an example, my fiance's company uses Docker, but they don't use Kubernetes or any kind of orchestration because they don't need to. Like the amount of the resources that they're using and the amount of the type and amount of work that they're doing, it doesn't make sense to use an orchestrator. And I've actually talked to some of the engineers about it, because they were like, oh, tell me about this Kubernetes thing. And I'm like, this is what it is, blah, blah, blah. And I kind of finally came up with a metaphor where it's like, your company uses the containers as a shovel. If we brought to let's say we're plowing a field, right? You've got a plow. If you were to use Kubernetes, that would be like trying to plow a field with a nuclear bomb. It's way more complicated than you need to do. Sure, you can clear a lot of land with a giant bomb, but that is way more than you guys need, right? And I think that for me, that's the drawing line. It's like, if the complexity makes sense for you to do, if you're trying to all of a sudden establish a farm, not to say that you should use a bomb to plow land, but hey, if you need to clear a lot of land, a bomb can work, right? That was a terrible metaphor. I'm sorry. That went off the rails really fast.
It wasn't too bad.
Josh, what do you think?
One thing that I'll say is, and this is just coming from experience working with organizations, is let's assume that you have justified Kubernetes for yourself. And by the way, I super echo everything Nicholas just said. You have to be really careful and determine, do you actually need to take this thing on? Because it's still hard to do in a lot of ways, right? But let's assume you have taken it on. I think an interesting thing to have empathy about, as oftentimes infrastructure, DevOps people, is you might know Kubernetes really, really well, but that doesn't mean your thousands and thousands of developers have any idea what Kubernetes is at all. And that is a massive disconnect we see in organizations all the time, where they're trying to onboard folks onto Kubernetes, and they haven't fully abstracted Kubernetes away, which some companies do, and that can be a really good pattern too. Like, developers deploy their apps, they don't even know Kubernetes are running them under the hood. That's a really neat pattern as well. But assuming that they're just trying to bring developers onto Kubernetes, they don't really have the same amount of empathy for them. And they just think this should be really easy. It's just a bunch of YAML files. You'll figure it out. But they totally forget about all the complexities that they originally learned about, like how does pod-to-pod networking work and things like that. So I just think to your question, Carlicia, it's interesting because one massive group in a company can know a lot about Kubernetes and forget what it was like to learn how something like Kubernetes or container orchestration worked. So I think a lot of that is kind of bridging the gap and really having some amount of education to bring everyone up to speed, even in the same organization.
I am dying to have an episode on just that alone, because it is quite challenging. When you are faced with Kubernetes, I mean, the very first thing is that there are terminologies that you haven't seen before. And then you're like, how does that map to what I already know? And then sometimes it doesn't map. It's completely new. So.
Yeah, when the benefits aren't super obvious to you, it's really hard to get bought in and be willing to invest your own time and energy into it, right? And we forget that it's not just super obvious why Kubernetes makes sense for a lot of folks. Yeah,
absolutely. That is a good point that even I sometimes forget. Where someone's like, well, why would I want Kubernetes? I'm like, why wouldn't you want Kubernetes? Duh. It works so well in my brain. Why don't you get it? But it's good to take a step back, right, out of yourself and, be empathetic to the people you're talking about in the community. I think, clearly, Sia, you mentioned that we should be wrapping this up pretty soon, and I think I totally agree. Before we go, I want to say, if you want to contribute to any container orchestration, but Kubernetes in specific, since that's the one that we kind of work with the most, we totally encourage you to start contributing to these projects. With Kubernetes, we have the Kubernetes repo that has a lot of information on how to start contributing. I believe that Mesosphere has their own repos and the information online available for them. And I don't know. And I believe, I'm not sure if there's much in the way of Docker Swarm anymore that you can contribute to. I'm not sure, but for Kubernetes, we have the Kubernetes repo and the Kubernetes Slack channel, slack.kates.io. Please join us and start talking about your container orchestration journey.
And Kates, by the way, is KAS.
Yes.
And I'm going to say that because I was at an event and some people were up on the stage and Kates this, Kates that. And I'm sitting with some mods in the back and I'm like, who's Kate?
Yeah. Or I've seen people K8S is the acronym. And what that means is that there's 8 letters between K and S in Kubernetes. That's all that means. I've seen some people do K8 and it drives me up every wall. I actually start constructing walls and it continues to drive me up them. I'm in an infinite regression of walls.
All right, everybody. Thank you for listening. Great that you're here. And we are going to be back with more cloud native goodness.
Yeah, absolutely. All right, cheers.
Thanks.
Bye.